Hey guys, I heard people were having trouble with the last couple sections of the Delta Math. So in this video, I'm just going to do a couple problems from each section, and hopefully that will help clear things up for you. So in this section, you're given the graph of an exponential function. Remember, we haven't done logs yet, and you just have to describe some of the features. Okay, so first off, just looking at this graph, look for asymptotes, right? We know this is exponential because we haven't done logarithmic yet. What kind of asymptote does it have? It has a horizontal asymptote along the x-axis here, flattens out along the x-axis. The equation for the x-axis is y equals 0 because all along the x-axis is a horizontal line with a y value of 0. The range, how far up and down the function goes, well, what's the lowest that it goes? See how it points down to negative infinity? Right? Points down to negative infinity. What's the highest that it goes? Well, because we have that asymptote at 0, right? That's the highest we're going to go. We're going to get really close to 0 and never touch it. This function is, as I move left to right, the graph goes up. So we say the function is increasing on its domain. As far as domain goes, one of the things that we talked about was that exponential functions, their domain is always negative infinity to positive infinity, all real numbers, because you can plug in whatever you want into this function. Okay, you can raise 1/2 to whatever power you want, right? You can plug in any x value you want, so the domain is all real numbers. The end behavior on the left side, so as I move to the left, okay, as I move to the left, so as x approaches negative infinity, there's nothing stopping me from moving to the left. Which way does the arrow point? The arrow points down to negative infinity. So as I go to the left, as x approaches negative infinity, y approaches negative infinity as well. On the right side, I can move as far as I want to the right, so x is approaching infinity. However, that asymptote is stopping us from moving up past 0, so y is going to approach 0. Okay, let's make sure I clicked everything correctly. Let's see. There we go. Good stuff. See how it highlights the asymptote for us. Cool. Let's do one more. Okay, so this one's a little bit different compared to the last one. It still has an asymptote, but if you notice, it's not on the x-axis here. So again, still an exponential function. Still a horizontal asymptote. Okay, horizontal lines are always y equals. And think about what's the y value that we're approaching but never crossing? -4. The range, how far up and down? Well, the lowest that the function goes is -4. And the highest that the function goes, it points up on the left side, is infinity. As I move left to right, what is this function doing? Is it going up or is it going down? It's going down. It's decreasing, right? The ball is rolling down the ramp. Domain, always all real numbers for exponentials. I can plug whatever I want in to this function. I can raise 1/2 to whatever power I want. Okay. The end behavior on the left side. So as I go to the left, the function goes up. There's nothing stopping me from going to the left, so I can go all the way out to negative infinity on the x-axis, and the function is going to go up on the y-axis. On the right side, as we go to the right side of our domain, so as we go towards infinity, what are we approaching? Well, we're never going to cross -4. We're never going to go below that. Okay, and if you notice the end behavior, the things that you choose for x approaches negative infinity, x approaches infinity, that should match up with the domain. The stuff on the right side should match up with the range, right? I'm decreasing, so I'm starting at infinity, and I'm going down to -4. All this stuff is connected. Nice. All right. Let's go to the next section. So in the next section, we're told to graph this function -3 to the x plus 1. Okay, what kind of asymptote do we have? Remember, it's always a horizontal asymptote. Okay, it's always a horizontal asymptote. And one thing to note is, I'm actually going to pop over to Smart Notes. Let's do that. When it comes to asymptotes, okay, if we were to graph just like, I don't know, y equals 2 to the x, what we would have is we'd have a function with the horizontal asymptote, let's make that a little bit neater, on the x-axis, right? And we move up on the right side. If we were to add 1 to that, y equals 2 to the x plus 1, well, I'm taking the whole function, think about transformations, and I'm doing a vertical shift up 1. So this asymptote is getting moved up 1. So I would have a new asymptote at 1. So think about for this graph, we know we're going to have a horizontal asymptote. Okay, and because we have this plus 1 on the end, think about function transformations. We're going to have a horizontal asymptote at 1. So let's hop back over to Delta Math. And we're going to drag this asymptote up to 1. Okay, don't worry about what the graph looks like right now. Okay, now we're going to plot the graph. And the easiest way to plot the graph is to pick a couple points that are very easy to work with. So if we have, and we're going to make a table here. So on one side we'll have x. On the other side we'll have our function f of x equals -3 to the x plus 1. Some easy things to pick are 0, 1, and 2. Why? Because it's easy to raise things to the 0 power, to the first power, and to the second power. So -3 to the 0 plus 1. Anything to the 0 power is 1. So I have -1 plus 1, or 0. Okay. Now keep in mind, there really should be parentheses around this 3. Okay, we're not taking -3 and raising it to a power, otherwise the negative would be in parentheses up here. Okay, so if you don't see parentheses, imagine the negative being applied at the end after you raise it to an exponent. So we're going to do -3 to the 1 plus 1. Okay, well 3 to the 1 is 3, so I have -3 plus 1, which is -2. Okay, we'll do it one more time. -3 squared plus 1. So I have -3 squared is 9 plus 1, -8. So we can plot a couple points. So we'll have 0, 0, 1, -2, and 2, -8. So it looks like this function is going to decrease. Wow, I can't draw today. Is going to decrease. I still can't draw. Okay, that's good enough. It's going to decrease on the right, and we'll have an asymptote on the left. Okay, so let's move away from my crappy drawing and see if we can do that in Desmos. So 0, 0, 1, -2. And if we go down to 2, there's 2, -8. All right, let's see if we did this right. There we go. Let's see if it gives us an explanation here. It gives us some possible points, and it used the same points that we did. Cool. One more. One more. Okay. So we have -2 times 1/2 to the x plus 4. Again, always a horizontal asymptote. Okay. And let's think about function transformations for a second. How does that plus 4 affect the location of the asymptote? How does that plus 4 affect the location of the asymptote? Well, normally our asymptote is at 0. So we're going to shift it up 4 to plus 4. We'll make another table again. Do a little sketch. That's why I always suggest when you're doing, even when you're doing delta math, like have some scrap paper out so you can do, like make your tables and whatnot. Okay, so we're going to ignore the line on here. This line doesn't mean anything. So we need x, and then -2 times 1/2 to the x plus 4. Okay. Now this one might be a little more tricky. Unfortunately, with delta math, we just need a couple of points here. So let's try 0, see what we get. So -2 times 1/2 to the 0 plus 4. Well, that's -2 times anything to the 0 power is 1 plus 4. -2 plus 4, +2. So we know at 0, we should have a y-intercept of 2. Let's try 1. So -2 times 1/2 to the 1 plus 4. Well, anything to the first power is just itself. So that's -2 times 1/2. So what is this? -2 times 1/2, -1 plus 4, or 3. Okay. Let's see if that does it. So we're going to go up to 0, 2. And what was it? 1, 3. Okay, that matches our, we got our asymptote all lined up there. Let's see how we did. There we go. Right on. All right, well, I hope this was helpful. If you have any questions, feel free to email me. I'll see you later.